Well, this video is going to start off in the 5C indexer in the mill. And as you bring the cutter down, do yourself a favor. Start on 0, take a test cut, spin it 180 degrees following the initial test cut. And now you have two parallel surfaces. This is a good time where you can check the distance between those two flats, make your offset, and take each additional pass to follow. It saves you a lot of time if you take two parallel sides instead of making the entire hex initially. I'm going right to finish size here. I'm indexing every 60 degrees. Going right to the face of the collet. This is going to end up as a 140 hex. That's about 3.5 millimeters. I'm going to relocate that exact same collet from the spin indexer into the lathe. And I'm going to center drill and drill the material for the thread that goes through the center. This is a 256 thread. It's about 84 thousandths in diameter, 85 thousandths in diameter, just a little bit over 2 millimeters in diameter. Take your time, don't push brass because the drill can easily walk in brass. Make sure all your tools are nice and sharp. This material is sticking out about 13 millimeters out of that collet, about 530 imperial. Chamfering a thread before you actually run the thread reduces the potential for rolling over the first thread. So if you were to tap this and then chamfer it, you risk rolling that first thread over. Slight break edge on the edge of the hex so it looks like a real nut. And with a spring-loaded tap guide appropriately positioned, I'm going to drive this 256 tap down in this material about as far as I can go to make sure that as I part these components off, each one should be adequately threaded. And back it out. Coordinating all your tools and having all your readings and dial settings written down on a little cheat sheet alongside the work is always a good idea. I keep a pad on my headstock and I review the numbers as I work. The facing tool is 0 and everything from that point on has a digital readout value and cross slide value as well. Right down to the parting tool. I know that my parting tool is 180 thousandths different than the facing tool, so whatever I need to cut off thickness wise, I just add that 180 to the value of the thickness of the part and I get exactly what I'm looking for, usually within 5-10 thousandths of an inch. And sometimes it's just unavoidable that you will have to countersink over an existing thread. Just be aware that you did that and float a tap through it when you're done. The operation that you're watching now is the facing, chamfering, and deburring of the second side of the little nuts. Now, anybody that's ever tried this knows that it's difficult to make a threaded arbor that will allow you to control the projection of that thread so that whatever tiny little piece you're sticking on there sits the way you want it to sit. Well, the easy way around that is to make that threaded stud that sticks out on your arbor, make it longer and put a collar over top of it. You can see that what you're looking at right there, that's actually 3 pieces: the arbor, a collar, and the nut that I'm working on. So watch for the collar to separate from the actual threaded arbor. This gives you tremendous control over the actual part. There you go. Collar just came off. I'm going to put the collar back on, put one of the nuts on. Come on, there you go. And now I have the projection that I need. The collar allows you a positive stop and allows you to use the same digital values or dial indicator values so that all of your parts will come out the same. Using that collar is a great trick. Keep it in mind, guys. It's a good one for the toolbox. All right, we have 256 nuts. They are 070 thick. There's the arbor that I used. And you can see that the thread on the arbor does not run all the way to the shoulder, but I create a hard shoulder with the collar. It works out really well. Make sure you put that one in your toolbox. Sizing up the material now, we are at 437. That is about 9 millimeters, I guess. We're going to need 4 of these components. I may not show all 4 being produced. And if you've seen my other videos on turning extended small diameters, that certainly could be taken in one shot, but it's just not worth it. So we have a small diameter, and now we're going to put a chamfer on it. I'm watching my digital, so I know exactly where to stop that chamfer tool. And the tool is preset. Do it with an eye loop. You'll see me look in there with a small magnifier from time to time. Shine it up. And the best thing about this procedure here is I'm doing these 2 at a time on opposite ends of exactly the same length blank. So I have 2 blanks that are the same length, and I can flip it around and I can make 4 pieces without ever changing the stop or changing the values or resetting anything. It's a good way to do these parts. Once all the turning is complete, it's time to thread them. This is, like I said before, a 256 thread. 56 threads per inch, 85 thousandths inch in diameter. So it's pretty small. The video makes it look a lot larger than it is. And being in brass, you could probably snap this off pretty easy if the tools aren't sharp. Make sure that whatever material grows as the tool penetrates the material, make sure you take that off and maintain the OD of the material. But since this is a soft material like brass, be very careful with the emery or whatever device you use to take the burrs off, because you'll reduce that OD pretty quick. And just flip it around, use all the exact same numbers for the next 3 pieces. All right, guys. Any guesses yet? Write in the comment line if you think you know what it is. Next feature we're going to put on is another hex. This hex will terminate where the conical section of that, where the angle originates. So we had a small diameter, a little bit larger diameter, and an angle. I am turning that secondary diameter into a hex. This hex is the same size as the nuts we made previously. Part is now put back in the lathe. And just so that the little hexes that I just put on there look authentic, I am using an angled tool and I am breaking off the corners of each of the parts and preparing them cosmetically for the next operation. There are 2 of these planks. 4 pieces total. The stop inside the collet has been moved forward so the part projects a little bit farther out. I'm going into the parting operation at this time. Now I'm not going to be able to part off each piece from both ends of each slug. I need to take 1 piece from the end of each slug and reset the stop. Because think about it, the part's going to get shorter, and if you turn the part around and stick it back in there, well, you're not going to have the setting that you want. So fresh slug on the second try. Make sure you deburr it before it falls completely off. It's a lot easier. And cut it off. I'm going to take it out. I'm going to change the setting. Actually, I'm going to make sure that the blanks are exactly the same length. Put the other one in there and face that off to the same length without moving the carriage. Now I'll change the stop inside the collet. Quick tweak on the Allen screw. Stop moves forward. Put the collet back in. There you go. Reset the parting tool. Cut the final 2 pieces off. Off camera, I took the liberty of producing an arbor that will allow me to screw these pieces into it. It is a 30-degree dish face that I did with a small boring bar. And I counterbored it to clear the hex, and I ran a 256 tap through this part. The arbor that is currently holding the part that I'm facing right now is resting against a stop inside this collet. This is brass. This is an extremely small thread, and I will not push this. Although the conical contact does give you a tremendous amount of grip and surface contact, it's still being held in place by a 256 brass screw, and I wouldn't push my luck. This particular feature is optional. If you do not care to do this, that is entirely up to you. But I'm putting a 440 screw in the bottom of this particular device. Now when this is actually assembled and it is at installation, chances are you'll never know that this 440 thread exists. This is going to be face down on whatever mounting surface that you elect to use. And this screw, the mounting screw that goes in this threaded hole, will be coming up from underneath whatever display base you decide to use. So this is a mounting feature and not a functional feature. And you got to do this to all 4 pieces. And by the way, this is not on the print. This is something that I just thought would look awesome, so I'm going to do it. Using my spring-loaded tap guide, and you're going to see these little stops that I put on there. This one is a little bit bigger ID than the OD of the tap. So if it looks like it's running out, that is not the tap that's running out. That is the stop collar that is running out. The bottom tap is especially bad. Watch this one wiggle around. Yeah, that's not pretty, but I can promise you. I'll back off the spring-loaded here for a second and show you that it's running relatively true. There you go. It's not running as bad as that collar makes it look, that's for sure. And the way I decided to unlock it, keeping the collar the same size as the arbor, there's the 440 screw going in. I can just simply reverse the entire mechanism, hold it in the same setup, add a piece of rubber and unscrew it. And it just comes out like a charm. 4 pieces. If you have this kit or you buy this kit, these particular holes that I'm putting in now are called out basically as a dealer's choice. You can put whatever you want here to secure this lathe to whatever display base you decide to secure it to. You do not need these holes if you want to just move this thing around, but it's up to you. I'm tapping 256 holes in the bottom of these legs. Try to position the holes that you drill and ultimately tap so that as the tap passes through, you don't encounter any of the cast surfaces on the inside. So as much as it would be nice to have these holes directly in the center of this small square pad on the bottom, because of the wall thicknesses on the 2 sides, the hole definitely needs to be biased off center. So that's why it looks like it does if you're curious. 4 holes. I am currently assembling the legs to the bottom of the bed that I just put the rack on in an earlier video. And as I sit here, it is 96 degrees in the shop with a heat index of about 105. So it is quite warm. And I am looking forward to leaving for the day. I have 2 fans on me, and thank God none of these pieces are made out of paper. They'd all be blowing off the table. But I think it's pretty clear by now that these are small leveling feet for this miniature lathe. And there's no particular scale to it. I know this is a 1/12 model, but I just went with what I thought looked good. So the 437 diameter, 30 degrees, I just thought that looked good. Leave a comment in the comment line if you like the scale of this. But I am very pleased with the way it came out. I think that looks great. I'm going to take it inside, sit on a surface plate, and give you a close-up look at it once I get all these things dialed in. The nuts that I made previously are on here, so you can actually lock these down. And if you had 2 small wrenches, you could adjust one while you had the other one loose and then tighten everything up. So yeah, they're legit. They do not swivel. Please don't bang on me for that. Maybe next time. And in closing, we take a ground level look across the granite surface plate just to show you what they look like. I am extremely pleased with this. And being as tall as I am, it was always nice when my employers would put my machines up on blocks or raise the elevator screws. It was just much more comfortable on your back. All right, we're going to pull back, give you a closing look at this. I'm very pleased with how this came out. And once again, I thank you for hanging in for the video. This is Joe Pye at Advanced Innovations in Austin, Texas. I'm out. Okay guys, pro tip of the week. Never put a thrust bearing between the nut and the center post on any quick change tool holder. This must securely engage the center column and secure the block to keep the block from potentially moving under load, driving the tool, the holder into the part or the chuck, causing serious damage and possible injury. Never use a thrust washer in that area right there. That is a bad idea.